yesterday video, we are going to discuss about the Kaplan turbine. So usually the turbine is a mechanical machine which is used to convert pressure energy of water into mechanical energy, okay? Or otherwise hydraulic energy is converted into a mechanical energy. So here mostly the turbines are used in dams. So in the dam we are having a catchment area. In the catchment area during rainy season water droplets are collected and it is stored in the dam. And we are storing the hydraulic energy of water in terms of potential energy. So once we release the water in the dam, the potential energy is converted into a kinetic energy. So the kinetic energy is used to run the turbine blades so that hydraulic energy is converted into a mechanical energy. So for in this experimental setup, we have a Kaplan turbine. So this is called a reactional turbine and axial turbine, axial and reaction turbine. So first I need to explain what is axial turbine. So here, this is the inlet of the turbine. This is the inlet of the turbine and this is the outlet of the turbine. So here, the water enters in the radial direction and it leaves the turbine in axial direction. So the axial pipe is also called the draft. Since the water is leaving from the turbine in axial direction, so it is called the axial turbine. And here we have a pressure energy and kinetic energy of water, and during the reactional force it is converted into a mechanical energy, so it is called a reactional turbine. So here this turbine is usually in the dam, this shaft of the turbine is connected with the generator so that we are generating the electric, we can able to generate the electric power. But here for the experimental purpose, this is connected with the mechanical load so that we can give the load based on the performance behavior of the turbine we can able to study. So for study purpose we have to calculate the efficiency of the turbine. Once we given the mechanical load, what about the efficiency of the turbine? And we know that the efficiency of is nothing but the output by input. So the output of the turbine and the input of the turbine. Where the output of the turbine is a mechanical force, so we can measure the power in terms of formula that is 2 pi nt by 60, where T is the torque, and the torque can be calculated by knowing the diameter and the load. So what is the load we are giving and the diameter of the breakdown. So how much torque is exerted. And during input power it can be calculated by means of the formula WQH, where W is the weight density of the water, that is 9810, then Q is the discharge. So to measure the discharge we have a ventimeter. So this is a very large ventimeter. By knowing the pressure difference between these two areas we can calculate the discharge. So one is inlet of the ventimeter. We have to calculate the area of the inlet, and this is called the throat. So throat diameter we have to measure and we need to calculate the throat area. And we have to measure the inlet pressure and throat pressure. It is directly connected with the pressure gauge, so no need to use manometers or differential manometers. It is directly displayed in the reading. So in the pressure gauge we have two readings, that is kilogram per centimeter square and pounds. So by knowing the pressure we can take the reading and we can give the load by some mechanical load with our load blocks that is added in the breakdown, and how the torque is exerted we can able to indirectly measure the technical formula. And the speed can be measured by means of speed sensor, and it is displayed in the unit. So we are setting the constant speed as 1000 rpm. For the constant speed we can vary the load and we can measure the performance characteristics of the curve. Finally this is displayed in terms of the readings are displayed in terms of graphs. Okay, so this is how the turbine will work, and we can make an experiment of the turbine. If you have any questions, you can ask me.
How can we control the speed of it?
Yes, for controlling the speed, so the power of the turbine is depends upon the water flow, how much water we are that is entering into the turbine. For that we have a gate valve. By opening and closing the gate valve, we can control the flow rate. By controlling the flow rate, we can control the speed of the turbine.
How does the mechanical load affect the performance of the turbine?
Yes, mechanical load, we are giving the mechanical load, it acts against the rotation of the turbine. So therefore, if you increase the load, then the torque increases, then the speed reduces. So we know that torque and speed is inversely proportional. So if you increase the torque and the speed reduces, and some amount of water is leaked in terms of slip, that is hydraulic slip, so that we can calculate it and we can measure the performance. So I hope this video is useful to you. Thank you for watching this.